guys, welcome back to another GeekaWhat video. And in this video, we're back with some more awesome 12th gen gaming PC builds. In this video, I've picked up an RTX 3080 Ti from GeekaWhat, one of their awesome Z690 motherboards, and the new i7 12700K. In this video, I'll not only be running through all of these component choices, but I'll be putting the system together from start right through to finish, showing you guys the build process and then the performance numbers a bit later on. And yes, we have tested out the brand new COD Vanguard and Forza Horizon 5. Make sure to get subscribed if you aren't already, but let's dive into it. Let's swap out this GPU for the motherboard and begin by looking at the motherboard, CPU, storage, RAM and cooler. What all of these components have in common is that we can install them all before worrying about the case today, making things nice and easy, especially for a first time builder. At the heart of this system is the brand new GeekaWhat AORUS Z690 Pro. This is a pretty high-end Z690 motherboard, not quite as high-end as AORUS's own masterboard, but it still gives you support for DDR5 and PCIe 5. That means that when Gen 4 SSDs are no longer quick enough, this board has got you covered, supporting that Generation 5 standard. Taking a top-down view of the motherboard, you can see our LGA 1700 socket, supporting those 12th gen processors, 4 RAM DIMM slots for our DDR5 memory, and all of our M.2 heatsinks and PCIe slots down the bottom. Now, inside of the motherboard, I'll be installing this, the CPU choice for this system, Intel's 12700K. I'd argue that this has been one of the more overlooked CPUs of the recent launch. It's still a great chip though, with Intel's efficiency and performance cores, awesome single and multi-threaded performance, and basically performance that outruns AMD quite conclusively. To install it, you want to go ahead and locate the little triangle on the corner of the CPU, and you want to match this up with the bottom left corner of our CPU socket. Now, the installation process for this build is a bit different to what you might be used to from Intel. Unlike the last generation of CPUs and many of the chips before it, this socket actually opens from the top and from the bottom, rather than just tilting from the top of the motherboard. You can then go ahead, drop your CPU nice and gently into place, no pressure or force is required, give it a bit of a wiggle to make sure it's seated correctly before returning your cover. The black plastic cover will pop off and then you can push that retention arm down. Bit of pressure but nothing too forceful. Keep this cover safe as you might need it should you ever want to send your motherboard back. The next component we're going to install is the RAM or the memory. This Vengeance DDR5 kit has a clock speed of 5200 MHz, pretty standard, and the Intel chips struggle to leverage that speed yet anyway, and a really basic design that doesn't break the bank, at least as far as DDR5 goes. Similarly to DDR4, to get dual channel performance, you have to use specific slots to allow that memory to run with the extra bandwidth. For us today, we'll be using the 2nd and 4th RAM DIMM slots on the motherboard. To be clear, that's this slot here and that slot at the back. You want to go ahead and locate the notch on the RAM DIMM itself, so you'll find a little notch on that golden contact strip, and you want to line this up with the corresponding notches on the DIMM slots. Pull back the retention clips on the 2nd and 4th slots, slide that RAM nice and easily into place, applying a bit of pressure, and it will clip into place. Simply repeat for as many of your RAM DIMMs as you've got. For us today, just the 2, so alternating slots, and that's basically all there is to it. With the RAM installed then, we can next add in our storage. For the storage in this system, I've selected a WD Black Gen 4 NVMe drive. With read speeds in the region of 7 GB a second and writes in the region of about 5.3 GB a second, it's certainly a quick drive. Maybe not quite as snappy as something like Seagate's FireCuda 530, but still, in the grand scheme of things, a pretty quick option. The latest CPUs and GPUs can bottleneck as well if you haven't got fast enough storage, making this a really crucial purchase. For this step, you have to chuck away, quite literally, your large screwdriver and pick up one of these, a teeny tiny screwdriver that's more suited to the compact screws you'll find on the M.2 slots. We'll be installing our drive today into the very, very top slot, so go ahead and remove the screws on each side of this metal heatsink, and then once you've done that, you should nicely be able to expose the M.2 slot itself. Before we actually go ahead and install the drive, you'll see we've got this kind of blue heatsink cover. Now this is on top of the thermal pad, and that's what will create the bond between the SSD and the metal of the heat spreader. You also need to repeat this step for the top M.2 slot, and once that's been done, these are pretty much primed and ready to go. You can then focus on installing the drive itself, something we'll do by sliding the drive in at sort of a 45-degree angle, aka not completely straight. Clip it into place, push it back down, and then we can return the cover. You don't necessarily need to actually screw this into the standoff, as the cover itself will create a nice enough bit of resistance and a nice enough bond to secure the drive in without too much movement. Once that's done, our motherboard assembly, as we call it, is very nearly complete. The very final thing that we need to do is take this mounting hardware for our CPU cooler. Now, our GA1700 is a different socket that uses a different mounting process entirely than the last generation, meaning you'll need to pick up either an add-on kit or a cooler that comes with 1700 support out of the box. This hardware right here, including these male-to-male screws and thumb screws, this backplate, and then these metal brackets are what we'll be using for our H100i Elite Capellix. Pop the backplate through the rear of the motherboard, then add on our male-to-male screws and thumb screws on top. We'll be installing the actual water block a bit later, but doing this stage now will definitely make your life a lot easier. Trust me on that one. Once that's been done then, our motherboard is basically complete. And to move on, we need to look at our case today. Now this is the NZXT H510 Flow, a chassis that was designed to fix a lot of the problems people had with the original H510, H510 Elite, and to be honest, I really like it. I'm still a big fan of glass on the front of cases, so while a mesh version in this design is a welcome addition, don't discard the glass one completely if aesthetically it's more your vibe. For me though, this white and black sort of two-tone design will work perfectly today. On the inside of the chassis, I've definitely gone for a more blacked out colour scheme, but with a black motherboard tray that won't look particularly out of place. And the white accents on the 510 Flow will do a really good job of making this system stand out. I've said this before, and I'll say it again, there's no glamorous way to actually unbox a case that looks good on camera. So for this video, you're just going to have to deal with it, I'm afraid, ladies and gents. If we spin the case around, you'll actually find this white included case accessory box. This contains all the screws and standoffs that we need to install the motherboard. This can be one of the more fiddly parts of a build, so if you're watching at home and want to copy, take careful notice of these next steps. Locate each of the standoff holes through the motherboard. You'll often have 3 at the top, 3 in the middle, and 3 along the bottom. These are in line and perfectly symmetrical, great to make things that little bit easier. And they should then correlate to standoffs you've actually got installed in the case. So for us today, we've got 3 at the top already. That's a win. We've got 3 across the middle. This is looking good. And then a further 3 along the bottom. That is literally perfect, allowing us to slide the motherboard in without needing to worry. In fact, it really is that simple with this motherboard, as it also has a built-in rear I/O shield, meaning you haven't got to worry about clipping that in. Once the board's in place, fasten it down through all of those 9 standoff holes. The centre standoff is actually slightly raised, which will hold the motherboard into place while you do this next step. Once this is done, we can move on to the cooler. And if one thing's become clear with the 12th gen processors, is that they do run a significant piece hotter than their 11th generation counterparts. Some people have made a huge deal out of this, talking about thermal throttling, a fundamental design flaw, and I don't agree. Do they run hotter? Yes. Do they use more power? Yes. But they give out a hell of a lot more performance. And in our real world testing, we haven't been seeing the 95 degrees that people have been proclaiming, at least when it comes to games. Now you'll notice that we already did a lot of the legwork earlier on for the CPU cooler. But for now, we're going to go ahead, remove this front radiator mount and install the radiator onto that mount to begin with. Before doing any of that though, we need to remove the stock NZXT fan. If you wanted a bit more airflow, you could add this into the top of the case, but I might try and pop in some RGB units instead. Either way though, having a radiator at the front could be a really solid way of actually giving you a bit more airflow, so that's definitely something to consider. For this step, we're going to refer back to some of the extra GA1700 mounting hardware from earlier. These are going to slide onto the bottom of the cooler, and then to the top of the cooler, and then fasten onto those 4 posts that we actually popped in a little moment ago. So you can see here on the motherboard itself, we've got our 4 posts with the thumb screws pre-installed. Take the thumb screws off, drop on a dab of thermal paste, and then secure the cooler into place. Nice and easily, corner by corner, and with that, our 12700K should, in theory, be nice and chilly. Nicely done. We can move on then next up to the graphics card. Now the GPU is undoubtedly the beating heart of basically any gaming PC build. And I appreciate in the current climate they're very, very difficult to get your hands on. This GeekaWhat 3080 Ti though is absolutely awesome if you can manage to find it. I've been a huge fan of GeekaWhat's latest innovations. I think they've really upped their game when it comes to GPUs and motherboards, catching up with and arguably overtaking the likes of MSI and Asus on some of their product SKUs. And the Eagle OC cooler is definitely one of them. With factory overclocked clock speeds, a triple fan design that keeps things nice and cool, and all in all quite a neutral aesthetic that works well with any build, maybe a little bit on the grey and plasticky side for me, but the MSRPs of these GPUs reflect that. In order to install the GPU, it's not quite as simple as sliding it in and away you go. We need to remove a couple of our PCIe lane covers at the rear of the case. For this, hover your GPU over the white PCIe 5.0 slot on the motherboard. Bit of a squeeze I appreciate, and this indicates we need to take out the second and third PCIe covers. Once these are out, the GPU will click into place. A little something like this. Here we go, nice and easily. It's a little bit of a squeeze, I will admit, before clipping it into place. That looks awesome. Most definitely a very tight fit, but not touching up against the radiator or anything like that. You just couldn't run a push-pull fan configuration, even if you wanted to, I don't believe, in this chassis. Fasten it down with some screws, and then we'll go ahead and get it wired and powered up in just a moment with the power supply choice. This right here is NZXT's C850. I think given how powerful the new Intel chips are, and of course the 3080 Ti, 850 watts or 1000 watts actually isn't going to be overkill for once. It's got plenty of power cables to wire up the GPU, the 24-pin motherboard cable and our CPU power connector, while giving us 80 plus gold efficiency and a fully modular interface. For now though, let's get the system booted up, seeing how good it looks when all those RGB lights are on and all those snazzy fans are spinning, and then take a dive into the world of performance, seeing how it stacks up in around 15 of our favourite and your guys' favourite titles too. I'll see you in a second for the benchmarks, but first, you know what's coming, roll that montage. Moving on to the performance and benchmark section of this video, it's now time to see just how well this system performs in a wide range of titles. The summary view on your screen gives you a good idea of all the different results we're able to gather, but we will be diving into these one by one, kicking off with GTA 5. Slightly on the older end of the spectrum, this is always a great benchmarking test, and you can go back from the last 5 years and compare lots of different systems and see what numbers they achieve. At 4K high settings, we managed to get 148 frames per second on average in GTA 5, with strong 90 and 99th percentile results which showed us some consistent frame rates. Next up on the list is a brand new title, Battlefield 2042. Through EA's early access, we tested the game with both ray tracing on and ray tracing off. Kicking things off at 4K ultra settings with RTX disabled, we got 84 frames per second on average. Good to see us wow breaking that 60 frames per second mark, and the system all in all performed really well. Turning ray tracing on in the next test was likely to drop our frame rate down quite significantly, but through the power of Nvidia's DLSS, their fancy AI resolution scaler, the hit can be minimised. We managed to achieve 76 frames per second with both ray tracing and DLSS on average, with our 90th percentile results never really dropping below the 60 mark, important for a first-person shooter. Moving on to Call of Duty's Vanguard, here we first tested out at 4K high settings with DLSS disabled. We managed to achieve 110 frames per second at 4K high settings, which is crazy, but it gets even better. Enable DLSS and we jump up to 131 FPS on average. Lovely. Next up on the list is Forza Horizon 5, the follow-up to my favourite game of all time, Forza Horizon 4, which was the follow-up to my favourite game of all time, Forza Horizon 3. In this title, we tested out at 4K ultra settings in the game's inbuilt benchmarking mode and managed to achieve just shy of 95 frames per second on average. Remember, for a racing game like this, 60 FPS is more than enough, so to be sitting at 94 at 4K is the best way of doing things. There's no point tuning the resolution down to get more frame rate, as it's simply not needed. Moving on to Apex Legends next, this is one of, if not the most popular gaming title around right now. At 4K high settings, we achieved 131 frames per second on average, with consistent 90 and 99th percentile. Next up on the list is Valorant. Lots and lots of different games today, and we tested here at 4K high setting. Valorant's a super easy game to run, and it shows in the numbers, 334 FPS on average. Next up on the list is Fortnite, a very, very popular game amongst our audience, and you'll be glad to know we tested at both 1080p high and 1080p low / competitive settings. At high settings, we got 250 frames per second on average, and the game looked pretty great. Tuning those settings down to low, basically 1080p competitive, we got 265, only gaining around about 15 frames per second, indicating a bottleneck, but this is pretty understandable when your worst case result is 250 FPS. Finally then, the last game we tested out was a bit of COD Warzone. Here at 4K high settings, we managed to achieve 110 frames per second on average, giving us some great results for both of our Call of Duties. And with that, that basically wraps it up for the performance section of this video and the video as a whole. If you enjoyed this one, make sure to get subscribed. Thanks for tuning in though, and as always, we'll see you in the next one.